This is the final video, the sixth video, for sequencing and introduction to hail. This video, I will talk about unlocking the power of the cloud with hail. This is in line with the 2021 virtual workshop on StatGen methods for human complex traits, hosted by the Institute for Behavioral Genetics, University of Colorado Boulder. My name is Kumar Virupin, and I am the Hail Support and Community Outreach Manager for Ben Neal's lab. The TAs for this module will be Tim Perturba, Caroline Diaz, Dan Horrigan, and John Compitello. Video, the learning objectives are: how can you leverage hail effectively on the cloud? What are the public compute clouds and how do they work? How can you run hail pipelines on the cloud? And what are the best practices for cost management? To be really frank with you, the cloud is the future of research computing. Because previously, where you bring data to the researchers, now you bring researchers to the data, and that's really in the form of the cloud that makes it really easy for data sharing as well. But the one thing that we always think about is like, oh wow, maybe the cloud computing is going to be really expensive. Not really. Especially if you follow a few key points on how to make sure that you have good practices that you follow into ensuring what you're doing is cost effective and, quite honestly, also works extremely cheap at the end of the day. I did mention rather briefly in the previous video that the UK Biobank Rapid GWA is done for every trait in the UK Biobank by Raymond Walters in Ben Neal's group was $1 a phenotype across 500,000 individuals. If that's not cheap, I don't know what else is. So when we think about the cloud, what are the pros and cons? So when you think about the pros, the advantages include many researchers can work on the same data at no additional cost. So you don't actually have to buy hard drives. You don't have to think about moving servers or sharing via some kind of FTP. You can just use the cloud and access it using virtual machines or Dataproc clusters. There's also no need to share resources with colleagues. You could just rent your own, so pay as you use. The one thing that Ben always reminds us is that there's a few things that we can follow from the Ben scientists. One of which that he did a while ago that I found completely unrelated, that I found very intriguing, is that in Ben Science, there's a lab manager that takes care of the entire lab. It's kind of like the middle person between him or the lab, the PI and the people of the lab. So he applied that to his lab by hiring someone known as a scientific advisor, who is Claire Churchhouse, who's actually, I think, the first scientific advisor, and now other PIs are following it because it's just so efficient. So similar to that thought process, he also believes that, like bench scientists who are allocated X amount of dollars or whatever monetary version that you're using or currency, you have X amount of dollars for Y amount of regions. Similarly to us, we can therefore use X amount of dollars for Y amount of time on the cloud, which is really good to also make using your money efficiently. If you come from a big lab with good funding, it just makes money management better. If you come from a small lab, like where I was in my grad school, then it also makes budgeting a lot better too, because if you go over, that's your own problem and you try to figure it out. And if you go under, then you get to do other analysis that you thought that you couldn't get to do before. Thirdly, high computer utilization means good cost efficiently. You pay for lots of CPU when you need them, and you pay nothing when you don't, which is, usually with the HPC, you just pay like a rental per month, and sometimes you just go on months of not working on it because you're writing grants, or you're working on papers, or you don't have high intensity use of the CPUs. There's also really great security and fault tolerance for data that even in the EU right now, the cloud is being used for some data sets, such as in FinGen, that I believe we do have a module on how data privacy is working, not in Hail, but in the IBG StatGen workshop. So there's also democratization because we don't need access to institutional HPC clusters to participate in research. You do still need funding. You do still need IRB approval before you use some of the data that you're thinking of using, but it makes it so much easier for data sharing. The disadvantages is that every operation has a cost. So an understanding of the cost model is very important, like weighing the time and cost estimate, which is what I'm going to go through briefly with you in a few moments and point you to a resource on the Hale documentation that would be really helpful, that would help you to look at the cost model. Secondly, the disadvantage would include it's really difficult to figure out how many resources do you need to position. Do you need a small cluster and then you'll waste your time? Do you need a large cluster and then you waste your money? So like having a small cluster but having a large data set but running for hours, which will work to about the same as having a medium scale cluster for a very short amount of time, because most of these are charged per hour. Too large a cluster, you'll waste your money because, what if you have such a small data set, but you applied for such a big cluster, and therefore this big cluster, you're just using it for a few minutes, but then you're paying it already by the hour, right? So the cost overruns do happen, and that's fine. You just have to make sure you do provision for it or allocate for it. However, cloud providers do sometimes refund when you do have erroneous errors. Let me see if I can. No, I can't backtrace it, but it doesn't matter. But the point is, sometimes if you talk to the cloud providers, and tell them something did something really awful, most of the time they do give you refunds. And if you do come from an institution that most people want to work on the cloud, you do get to apply for institutional rates as well, which is actually much cheaper. That's what we do at the Broad. So these are like the three main cloud computing platforms that I am aware of. There's for genomics. There are multiple other cloud computing platforms, but these are the three that are mainly used for genomics. And the best Hale support that I mentioned at the end of the last video is using Google Cloud. So let's talk about the cloud computing products from Google. In this would be the Google Storage, Google Compute Engine, and Google Data Proc. So for Google Storage, also sometimes known as Google Buckets, I used to think of like buckets going into the beach, like going onto the beach and making like sandcastles. But no, they're dissimilar. You're keeping data instead of sand or water, depending on what your water to sand ratio is. But back to computing. So Google Cloud Storage would be your Google Buckets that you can store your data, Python notebooks, anything you want. I may have alluded to this earlier or in our previous conversation, in our previous video, Google Cloud Storage tends to be about $25 per terabyte per month. If we compare this to like the Broad cluster, which is about $75 per terabyte per month. So Google Cloud Compute Engine would be the GCE, where you can rent your virtual machine and use it however you want. So if you think about it, it's like you renting a computer in the cloud and you're just sitting in the computer and you're running whatever analysis you want. It is a terminal Linux-based computer for the most part. You can change your OS. Most of the virtual machines that I've run is usually Ubuntu-based. So you can either choose the standard VMs or the preemptible VMs. VMs would be virtual machines. So the standards would be about 5 cents per hour and preemptibles would be 1. And this is another nuance when you think about the compute engine of standard versus preemptible, even when you're thinking about creating clusters using Dataproc, which is the next thing that we're going to talk about. So when it comes to standards, it means that you have priority to use it, you get to use it, and no one else gets to take it away from you, which is why you have priority and you're paying 5 cents per hour for it. As opposed to preemptibles, where you're paying 1 cent per hour for it, where in concept, the reason why it's cheaper is because if someone comes on anywhere in the world that needs a standard that, there's no standards available, your preemptible could be taken away from you for their analysis or their computing. So if you're running like a VM where you're just doing analysis like on the fly, I would suggest going for a standard. However, when it comes to running a Dataproc, I would suggest mostly using preemptible because it tends to be cheaper and you're using multiple CPUs. It really depends. So if you're running VEP, preemptibles, mix of preemptibles and standards would work. But I would really go with standard more just because there's a lot of shuffling that's involved. And what this means is because when you run Google Dataproc, which is the last thing, you essentially run a cluster of multiple computers. And with Hale, we utilize Apache Spark to distribute computing across the X number of CPUs that you run in your cluster. So if you have most of them, if not all, preemptibles, and some of them are taken away, and you're shuffling between the CPUs, that's not great. So for things that require high shuffling, like doing VEP annotations, use mostly standards. If you're, running your scripts just for QC, you can run preemptables. And this is like things that you learn on the fly, and you can ask us if you want in the discuss forum whenever you feel like it. But most of the time, like I would go with preemptables because it's cheaper, and whatever you pay for the cluster, like the amount of CPUs that you use, plus the 1 cent per CPU per hour is what you are estimating right now. So a tool that we have developed to manage Hail on the cloud that is included in your pip install Hail, which is Hail Control or Hail CTL. Hail Control Dataproc is the Hail equivalent for Cloud Manager for Google, and we are planning and in development for EMR for Amazon and Azure for Microsoft. I just love the way someone pronounces Azure. It sounds like fancy. Anyway, so common operations would be starting your cluster of how long, for instance, this flag you would like to run your cluster, your Dataproc to connect to your cluster. So upon starting it, connecting it to your My Cluster, and then effectively opening a notebook, and then submitting a script if you'd like, because if you don't want to do like coding on the fly with a Dataproc, not a virtual machine, then you could use this, and then if you want to submit, you could use this. And if you want to stop it, because you would eventually need to stop it, if not, you just continue procuring costs, you can stop your cluster. So some cost management best practices. When you go through the slide, there is a slide right before this that gives you some gsutil command that you use for GCP or Google Cloud Computing that I'll not be describing during the video, but you're welcome to look at it later. Now, when it comes to cost management, because a lot of people, when they think about the cloud, they get scared. There's nothing to be scared about. As long as you learn how to do these 3 things that we've mentioned over here, where first, develop small and then run big. And if you're working, and when you're working with genomic data, always make chromosome 22, your autosomal chromosome 22, your bestie. Why? Because it's the smallest chromosome. So when you iterate your pipelines and you're trying to debug your pipelines, work on chromosome 22 or even just a chunk on chromosome 22 just to see how your pipeline works. And once it works, then run your pipelines on the large clusters when you're ready. Secondly, manage your risks by setting your billing limits and alerts. So like when you run your analysis and you get your email every time you overspend, for instance. And this is when it comes to like cost and time that you'll have to take into consideration. When you think about time, the one recommendation that I would have is when you work with Hail, do something simple like just like when you're running your script, run a filter rows and compute the amount of time that you're running and then scale it up. It doesn't always work, but I would suggest going to our general advice to see other pieces of advice that we give you. Secondly, when it comes to time and how you would extrapolate your time, again using the small run big. So run small, see how long it takes, and then try to estimate the cost upon looking at the number of hours that you're going to take. We do have a quick tutorial on just a snippet of like how you would run this on the general advice column on managing costs. Secondly, on the managing risk, upon like sending the email and time and cost management, is always use max age and max idle flags on your cluster creation, where max age would be the number of hours that your cluster can run, and max idle is the number of hours that your cluster can run without anything actually running on it. Because sometimes you may just, because spinning up a cluster takes money, and shutting down a cluster also takes money because it's a time that it takes, right? So if you want to like, submit a script and then wait for the results and let it come out and then look at the results before you decide to run another set of script or rerun it again, you can use the max idle, for instance. And finally, use buckets with retention policies. So data that's deleted after X number of days or be moved to cold storage, which is like in cents or dollars whenever possible. And finally, the third thing that I would advise you is always plan ahead. Calculate your costs ahead of time whenever possible. Use this calculator and really everything will be easy for you. And that brings us to our learning. which is, well, you can now leverage Hail, hopefully, effectively on the cloud using some of the tools that were provided you and a lot of the documentation that we have. There are multiple public compute clouds, but Google Cloud has the most mature infrastructure to work with Hail, which is why we support Hail, which is why I support Google Cloud. There are tools like Hail Control and GSUtil, where I did not describe in this video, but in your slide deck, can help you easily get started running Hail pipelines on Google Dataproc. And finally, you should always develop your scripts on small data. Remember, start big, start small, run big. Plan very well and manage your risk by costing time by setting up alerts, lifetime alerts for expensive resources, which is on unlocking the power of the cloud with Hail. My name is Kumar Veerapan. If you have any questions, feel free to send me an email at veerapan@broadinstitute.org or send me a message at Kumar on Slack, the IVG Slack. Thank you very much, everyone. That brings us to the end of our entire 6-video series for sequencing and introduction to Hail. I appreciate your attention. If you want to revisit any of the videos, feel free to do that. If you have any questions, feel free to let us know. Otherwise, myself, Kumar, Tim, Carolyn, Dan, and John will see you for the 2 practical sessions, which are both exactly the same, just done in 2 different time zones, essentially on June 16, 2021. Thank you very much, everyone. Have a beautiful workshop.